You work with proportions when making images larger and smaller, finding unknown lengths of objects, cooking, and making scale models. This video lesson will teach you to define what a proportion is and cite real examples of proportions. Show how to keep images, models, and copies of objects in proportion as you increase or decrease sizes. Find an unknown dimension of an object that is in proportion to another version of the same object, like a television screen, photograph, or scale model. Let's start. What are proportions? A proportion is a compared ratio. Usually, you are ensuring that a given ratio is equivalent to another ratio by seeing if the two ratios are proportional. That is, whatever the dimensions are of one object, another object's dimensions are scaled up or down to maintain the same ratio of height to length, for example. Ratios can be equivalent or not equivalent. Ratios that are not equivalent could be larger or smaller than one another. Ratios that are equivalent are said to be in proportion or proportional. Let's look at how to solve proportions. To make sure things stay in proportion while increasing or decreasing their size, be sure to multiply all the numbers in the original ratio by the same amount. For example, if I was making brownies, I would use a ratio of 1 cup of flour to 1 cup of sugar, which is a ratio of 1 to 1. If I wanted to triple the amount of brownies and keep the same recipe, I would multiply each number in the ratio by 3. This would bring our ratio to 3 to 3 and means I would need 3 cups of flour and 3 cups of sugar to make triple the amount of brownies. To check your work, see if the ratios will divide into the same number. If they divide, then they are proportional. Let's take a look at an example. The ratios 2 to 5 and 6 to 15 are proportional because both divide into the same number. 2 divided by 5 equals 0.4, and 6 divided by 15 also equals 0.4. What about the ratios 4 to 10 and 5 to 10? Let's see. 4 divided by 10 equals 0.4, and 5 divided by 10 equals 0.5. These ratios are not proportional because they don't divide into the same number. Now let's look at an example of proportions that helps us make cookies. A recipe for 24 cookies, which is 2 dozen, needs 1 cup of flour. To scale the recipe up to make 12 dozen cookies, how much flour do you need? Set up your proportions comparing 24 and 144 cookies, or more easily, 2 dozen and 12 dozen cookies. 24 to 1 equals 144 to x. 2 dozen cookies needs 1 cup of flour. 12 dozen cookies needs x cups of flour. 2 to 1 equals 12 to x. You can write this as a fractional proportions like this. 2 divided by 1 equals 12 divided by x. Look at the relationship between the two numbers in our fractional proportions. What do you multiply 2 times to get 12? You multiply it times 6. So you multiply the denominator 1 times 6. You need 6 cups of flour to make 12 dozen cookies. Now let's take a look at an example for photography. A common American size of photograph for framing is a 5-inch by 7-inch, often written as shorthand as 5 by 7. If you want another version of the same photograph without cropping or cutting, you can get all these that are in the same proportion, ratio of height to length, by multiplying. By multiplying by 2, we get 10 by 14. By multiplying by 3, we get 15 by 21. By multiplying by 4, we get 20 by 28. It's that easy. Another common proportion is poster sizes. You may have a tiny picture that is 2 by 3, but that could be available in all these sizes, all in proportion to one another. You often see these dimensions used for electronics as aspect ratios, so a perfect image on a laptop is not cut off when viewed on a tablet or smartphone. Proportions are also used in constructing scale models for hobbyists, architects, engineers, and scientists. Models are easy to examine, as they are usually much smaller than the real object. Models are lightweight and portable and can help with decisions before expensive, real objects are constructed. An architectural model of a building may be in a scale so that 1 inch on the model is the same as 12 inches in real life. So the model has a ratio of 1 to 12 or a 1/12 scale. You can use proportions to calculate sizes of unknown dimensions, either on the model or on the actual object. Suppose you have a model of an experimental aircraft. The model is 1/100th or 1 to 100 scale. 1 centimeter on the model equals 100 centimeters or 1 meter on the real aircraft. You measure the model's cockpit canopy, which is the plastic shield over the pilot, and see it is 2 centimeters. How long will that be on the actual aircraft? Let's compare the proportions. 1 to 100 equals 2 to x. We can write this as a fractional proportion. 1 divided by 100 equals 2 divided by x. You can quickly see the answer is 200 centimeters or 2 meters. The real canopy will be 2 meters long. You can use proportion to check the accuracy of a model. The real aircraft's wheels should measure 50 centimeters, which is the same as 500 millimeters in diameter. How small should the wheels be on the aircraft model? In other words, what is 1/100th of 50 centimeters? First, let's write out our proportions. 1 to 100 equals x to 50 centimeters. Then let's convert centimeters to millimeters and see what it looks like. 1 to 100 equals x to 500 millimeters. Notice the first proportion keeps the original units, centimeters. So your answer, 0.5, will be in centimeters. 0.5 centimeters equals 5 millimeters. The other two ratios use the converted unit millimeters. What would you multiply 100 times to get 500? You would multiply it times 5. So multiply the 1 times 5. The model wheels should be 5 millimeters in diameter. Lesson summary. This lesson showed you the definition of proportion, gave you examples of proportions in everyday situations, and taught you how to keep images, scale models, and copies of objects in proportion as you increase or decrease their sizes. You are also now able to find an unknown dimension of an object that is in proportion to another version of the same object, like a television screen, photograph, framed picture, or scale model.